October 2017. Something shot into our solar system. It was moving too fast, coming from the wrong direction, and its shape made no sense. A faint speck of light, moving way too fast to be from our solar system. They named it Oumuamua. Our first ever interstellar visitor. And that's where the real mystery began. It wasn't just its origin that was strange. Its shape was completely wrong. Asteroids and comets are supposed to be lumpy, potato-shaped rocks. This thing was long and flat, either like a cigar, or even weirder, like a thin pancake tumbling through space. But its biggest anomaly was this. As it flew away from the sun, instead of slowing down, it accelerated. Like some unseen engine was giving it a push. The easy explanation was comet gas. But every telescope confirmed there was zero gas trail. Just a clean, non-gravitational push. This sent astronomers scrambling. They threw every theory they had at it. A new kind of comet made of pure hydrogen ice? A fragment of a shattered planet? Every natural explanation felt forced. Or was it not a natural object at all? Before we could get the data we needed to solve it, our time was up. Oumuamua was already too far, too fast. Our one chance to get a close look was gone forever. It vanished back into the interstellar dark, leaving us with nothing but ambiguous data and a raging debate. It left us with more questions than answers. But what if that was the point? What if Oumuamua wasn't the puzzle, but the question we were finally forced to ask? And now, we might finally have the tools to start answering it. And the tool to answer it? It wasn't some billion-dollar space telescope. It was already right here on Earth, working every single night. This is Atlas, a network of robotic telescopes. Its main mission isn't actually to find interstellar visitors, but to be our guardian, scanning the entire sky for asteroids on a potential collision course with Earth, our planetary defense line. But in doing its primary job, it accidentally became the perfect tool for finding objects like Oumuamua. And here's the secret to its genius: its massive coverage. Think of Atlas as a giant trolley net cast across the cosmic ocean. Its main goal is to catch the big tuna, the dangerous asteroids. But because its net is so vast and its mesh so fine, it also catches all the weird little fish. Those faint, fast-moving objects from interstellar space that would slip right through anyone else's net. Every single night, for years, this net gets pulled in, and its entire catch is stored in a massive database. Essentially, Atlas had accidentally created the most detailed catalog of every single tiny dot that moves weirdly in our sky. So when researchers finally dove into that catch, they didn't just find another Oumuamua. They found dozens. They found an entire hidden population of interstellar visitors. So, what did they actually find in all that data? They didn't just find one or two. They found 7 previously unknown interstellar object candidates. And that was just from analyzing a fraction of the data. They were all small, maybe just a few meters across, but the kicker is how often they show up. Atlas estimates there are something like 10,000 of these things within the volume of our solar system at any given time. So let that sink in. That means at any given moment, there are always relics from other stars passing nearby. Our solar system isn't some quiet place. It's more like a busy cosmic crossroads. And this solves Oumuamua's biggest puzzle. It wasn't weird. It was just the first one we spotted. With this much data, we now know Oumuamua was normal. It's a representative of a vast, vast population. This discovery changes everything. We don't have to argue about one weird object anymore. Now we can study the whole group. We can start to understand where they all come from and what types there are. Maybe some are metallic asteroids. Others could be icy comets ejected from other star systems. Each one is a time capsule from its homeworld. And the most exciting part, this is just the beginning. Atlas is still collecting data. Other telescopes will now start looking too. A flood of new discoveries is about to begin. So, what does all of this mean for us? This isn't just a cool fact. It fundamentally changes the scientific roadmap for exploring interstellar objects. Until now, a mission to reach an object like Oumuamua seemed impossible. There was one target, and it was already too far away. But now we have multiple targets, and crucially, we'll see them coming. Projects like Project Lyra suddenly become viable. We could launch a probe, wait for the next interstellar visitor to come close, and go meet it. Imagine being able to touch material from another star, to analyze its composition, to find out if it carries organic molecules or even water. The building blocks of life that might be shared between stars. This is our way to study other planetary systems without traveling light years. The universe is literally mailing us samples from across the galaxy. And this isn't some distant dream. The Vera Rubin Observatory will come online soon. And it's going to find many more of these things. We're about to have a catalog full of targets. We are standing on the brink of a new era in astronomy. not just observing stars from afar, but actually exploring the debris from them that passes through our neighborhood. And it all started with a question left behind by one lonely messenger. Oumuamua was never the end of a mystery solved. It was, in fact, something far greater. It was the opening of a gate, a silent announcement delivered across light millennia that the universe is far, far more bustling than we ever imagined. A message from the stars themselves. A gateway to the profound understanding that we are not isolated, adrift in a cold, empty cosmic corner. No, we are part of something far, far grander. We are an integral part of a dynamic, living galactic web. One that's constantly trading matter. Heavy elements from ancient stars, planet-forming cosmic dust, and perhaps one day, we will discover even the very seeds of life itself. Traversing the cosmic expanse. And all of this was unveiled, all this new understanding, simply because we chose to look more closely at what was already right in front of us. What a paradox! A humble mission to safeguard Earth from cosmic threats has inadvertently, fundamentally transformed how we comprehend our true place in this vast universe.